Alright, Mr. Claxton's Algebra 2 CP students. We're talking today about solving word problems by using systems of linear equations. So, what do we need for this? Well, first, I know that you could pause and read this if you wanted to. What I want to talk to you about is given information and implied information. Okay, given information and implied information. And perhaps, in order to understand how this applies to the whole process, the whole process here is listed out. These are all the things that we need to consider when we answer a word problem. Now, we're probably not going to think about these all at once, and it might seem overwhelming to look at A through E, but in the big picture here, the given information is what matters greatly. This given information, okay? So we are going to branch off on that given information. We have given explicitly right out there in front of your face and implied. So looking at a sample problem here, what we know about this problem? Well, we know that it's asking us how many copies. So we're going to get a number of copies. In order to create a two-variable system, we need to let x equal the number of copies and y equal the money. This particular system could be solved only with one variable, but we're not concerned with that right now. The given information, highlighted in pink, is that we have 90 cents for printing and mailing each copy, plus $600. That's an expense. Outlined in pink, that's an expense. So we then want to consider, well, what else are they telling us? Well, the price of the newsletter is $1.50 per copy. So that's how much they're going to be making. And I understand we're assuming that they're making $1.50. That's how much they're bringing in, rather, for each newsletter. So that's their income and their expense. And in business, it's always a great idea to make sure that you're going to be earning more than you're making, or at least know what that break-even point is. That break-even point happens when both this expression for the income and the expression for the expenses are set equal to each other. And you can see that if y equals 1.5x and y equals 0.9x plus 600, all we have to do is substitute this value in for the y to set up an equation. And so that's the goal there, to set up an equation. Then we can use, we use substitution, obviously, and then we can use inverse operations to solve by subtracting 0.9x on each side and then dividing by 0 6/10 on each side. And understand, at that value, after 1,000 copies, we know that the company will be bringing in as much as they're spending. So after 1,000 copies, I want you to ask yourself, well, what's happening after 1,000 copies? After 1,000 copies, well, they'll be making money beyond that. So they need to sell at least 1,000 copies to make money. Looking at, well, that's the same problem. Looking at the next example, in investing $10,000 in equipment to manufacture a new board game. All right, what are we trying to do here? Well, what is the question asking us? I know that you can read this. You could pause and read it if you wanted to. How many games? That's what we're looking for. How many games do we have to make in order to break even? Okay, you're going to, every game you make, by the way, you're going to sell. It's going to be an ideal world right now. We identify the variables to let x equal the number of games. We call that the independent variable. What depends on that is the money spent or earned. That depends on the number of games created. So looking at this system, we know that there's two different ways to solve it. We could solve it with one variable, but we only show you the two variable down here. So what two relationships are there with the money? So we look up here with the money. Well, you invest $10,000 in equipment to manufacture a new board game. Invest, okay? Each game costs $2.65 in materials, okay, and you plan to sell them for $20. So we have a lot of upfront costs up there. The upfront costs $10,000 because you're investing. That still costing you money out of pocket. And each game costs $2.65 in materials. So those are the costs. Those are our expenses. Okay, highlighted right here. Income, well, we're selling them for $20 a piece. Okay, it sells right there. Sell them for $20. So what we're doing here, we are setting our income equal to our expenses to figure out that break-even point. Now, interpreting, whenever we get a decimal, obviously we're not going to make 576 and 3,688 10,000ths of a game. Okay? So we're going to say we need to sell 577 games. We need to create and sell 577 games. All right. Moving on there, if you wanted to try this example, that would be, pause it, attempt the example, and we can check over it the next day of class. But I would like to speak with you about a question that may be on your quiz. And that was in the homework. We need to be able to set up these systems. You absolutely must identify what the question is asking. It wants us to find the length and width. Right there. Oh, I need a two-variable system here. I have to have two variables. This can't be solved with one variable. We're using a two-variable system. We could solve it with one variable, but we're not going to. Let W equal the width. Let L equal the length. All right? The implied knowledge here. So I talked about that given information and the implied. If you know the perimeter of a rectangle is 24 feet, then what you know is that twice the width plus twice the length is 24. That's the implied knowledge here. And if you do not get that implied knowledge, it makes for a very, very, very difficult. Actually, you'll probably just be very confused. Now, some of you may have a strong background in memorizing formulas, or some of you might have came about this a different way, knowing that you're going to have twice the width plus twice the length because we are dealing with a rectangle here. Now, this other equation, the length is 5 times the width. Well, is just means equals. So anytime we see is, when we're trying to create an equation, we're thinking is. Length equals 5 times the width. And that's how we get it down here. You'd probably use substitution for this problem. We have a bookstore. 4 package of pens and 2 notebooks cost $8. 1 package of pens and 3 notebooks cost $7.80. We're finding the cost of each item. How do we do that? Well, we have to first create a system of equations. And with that system, we want to create one equation based off of 4 multiplied times P, number of packages of pens, plus 2 multiplied times N, number of notebooks. That's going to be equal to 820. And then obviously we would follow the same method down here. 1 package of pens and 3 notebooks cost $7.80. Try writing that out. Again, this is going to be on your quiz, so I'm not going to do it for you. I'm just trying to let you set it up. Variable definition is extremely important in this process. You must define the variables. Even if you're not writing it out, you have to know what each variable means. In fact, I make you write it out. I hope this has been of some benefit to you, just to see how the different questions are laid out, with color. In this one right here, we have 40 questions. Your goal is to write an equation that represents, okay, there are 40 questions. If x is equal to the number of 4-point questions and y is equal to the number of 2-point questions, and there's 40 questions, well, then you're going to have x plus y set equal to 40. Now, this other equation down here, some people were getting, I have to multiply 2 by the number of 2-point questions. In this case, 2 would be multiplied by y. And I would like to write that right underneath the y's here. I'm going to add to that 4 multiplied by the x. And that's based on how I define my variables. So understand here, some may have considered that to be backwards, but I define my variables to let x be the number of 4-point questions and y to be the number of 2-point questions. That's why it's very important to be extremely organized and specific when solving systems of equations. Now, beyond this, I did not discuss how to solve these systems because we've been doing that for a long time. I just wanted to try to create a video that would help you out if you were really confused. So thank you very much for watching, and happy equation solving.